To the naked eye, it is invisible. To this machine, it is a certainty.
This is not just a rifle. It is the CheyTac M200 intervention, the king of snipers.
3 shots, 2.5 kilometers away, a target the size of a dinner plate. It holds the world record for the longest accurate shot. But how is such perfection built? Welcome to the Secret Factory, where science meets steel.
It begins as a solid block of 4140 chromoly steel. Heavy, cold, unforgiving.
This block will become the receiver, the heart of the gun that withstands 60,000 psi of pressure.
We don't stamp it, we mill it. A 5-axis CNC machine carves it like a sculpture.
It takes 15 hours just to carve this one part. Speed is the enemy of precision.
Once milled, it is measured, not with a ruler, but with a laser. If it is off by the width of a human hair, it is destroyed. Now we move to the barrel, the most critical component for accuracy.
The barrel starts as a solid steel bar. To make a hole this long and straight, we cannot use a normal drill.
The drill bit floats on a cushion of oil. It pushes through 30 inches of steel without deviating more than 1/1000th of an inch. But drilling is just the start. Now comes the violence. Cold hammer forging. A tungsten carbide mandrel, the negative shape of the barrel, is inserted inside the tube.
Then, 4 massive hammers pound the steel from all sides. 4 mechanical hammers strike the outside of the barrel simultaneously.
They strike 1,000 times a minute. They don't cut the rifling, they crush the steel onto the mandrel. The steel compresses, the grain structure.
This makes the barrel incredibly hard and the inside surface smooth as glass. But perfection requires a human touch. A master gunsmith performs hand lapping.
He pushes a lead slug back and forth through the barrel by hand for hours.
He is polishing the metal to a micron level. This reduces friction, giving the bullet more speed.
Finally, the barrel is fluted. Deep grooves are cut into the outside.
This reduces weight and increases the surface area for cooling. A hot barrel is an inaccurate barrel.
A perfect barrel is useless if the trigger is heavy. The shooter's heartbeat alone could throw the shot off by meters. We need a trigger that breaks like a glass rod. Crisp, instant, zero movement. These parts are not cut with blades. We use wire EDM. Electrical sparks erode the metal with atomic precision. The result is a sear engagement of less than a millimeter.
Now, the muzzle brake, that massive block at the end of the barrel, it is not for show.
The .408 round creates an explosion powerful enough to break a shoulder. The brake tames the beast.
But to hit a target 2 miles away, you must see it. We enter the optics lab. The glass for the scope starts as a raw crystal block. It is ground by diamond wheels. It is polished until it is invisible. Then, it is coated with rare earth minerals.
This coating allows light to enter, but prevents the enemy from seeing a reflection. The interior of the scope is purged with argon gas. This prevents fogging, even in the Arctic or the jungle.
Finally, the reticle is laser etched. The crosshair is thinner than a human hair.
The barrel, the trigger, the scope, they are ready to meet.
Assembly is not done by robots. It is done by one man, the master gunsmith.
He fits the barrel to the receiver. The threads must align perfectly. No force, just physics.
He checks the headspace, the distance between the bolt face and the bullet. The chassis is made of carbon fiber and aluminum. Lightweight, but rigid.
But the rifle is only half the system. The other half is the CheyTac ballistic computer.
You cannot just aim and shoot at 2 miles. You have to do calculus.
This computer measures air density, temperature, and even the rotation of the Earth.
It tells the sniper exactly how many clicks to dial on the scope.
Now, the system is complete, but it must prove itself. To the tunnel.
This is a 100-meter underground tube. No wind, no variables, just pure accuracy.
The first round is chambered. The bolt is locked.
The trigger breaks. The world's most aerodynamic bullet leaves the barrel at 3,000 feet per second.
3 shots are fired. We check the target.
This is called sub-minute of angle. It means at 2 miles, this gun is more accurate than the human heartbeat.
But it is not finished. It must survive the desert, the jungle, and the snow. It needs armor.
We apply Cerakote, a ceramic-based paint that is harder than steel.
It is baked in an oven at 300 degrees. The paint fuses with the metal, becoming a permanent shield against rust.
The rifle is reassembled and placed in its travel case. Cut foam protects the investment.
Included in the box, the rifle, the computer, and the test target, proving its perfection.
From a block of raw steel to a machine capable of hitting the impossible. This is the intervention. The king of long range.